Hi guys, welcome to my channel. Today let's let a Leet code question. The description of the question is as follows: that Alice and Bob continue. So if we see an Alice and Bob in the question, then it's automatically assumed or it's automatically understandable that it's based on a two-player game. So this is a similar question that they continue their game with pile of stones, and there are a number of piles arranged in a row. So what is a pile? Pile consists of a group of stones mounted one on each other. So the object of the game is to end with most of the stones. Okay, got the point. So we were also given that on each player's turn, a player can take all the stones present in the first X remaining piles, where X is any number that's from 1 to 2m, and then we set our m to be maximum of m and x, and we need to ensure it's a two-player game, so we need to ensure that both players play optimally. It's obvious, right? Alice will play the game so that he needs to win it, and Bob also will play the game so that he needs to win the game. So how would we proceed with this problem? So first, before writing for the code, I'll just write some note points. The first note point is both players play the game optimally, and this is true for every two-player game. No one will play the game so that they need to lose the game. And also, at each turn, X number of stones could be picked, where X can be any number from 1 to 2m. So initial, also I'll make a third note point. Initial value of m being 1. And what next? We need to add it. What next we need to add over here is that the game continues until all the stones are finished. Okay. And finally, last one is we need to assume that Alice and Bob play optimally. So let's just start with the first example. Given example, piles are 2, 7, 9, 4, 4. So first pile contains 2 stones, second pile contains 7 stones, followed by third pile which contains 9 stones, fourth pile contains 4 stones, fifth pile contains 4 stones again. So how would this work? Right. So initially Alice starts the game and M is 1. So X could be lying between 1 and 2. So I'll just say you that if Alice at the very beginning chose only one stone, so he need to take one pile of stones from the beginning. So Alice score will be having 2 at the very beginning. And in Alice took X as 1 and M is also 1, so M will again be set up to 1. And Bob now have two cases. Bob can take one stone or Bob can take two stones again. I'm assuming that Bob plays the game optimally, right? So if Bob plays the game optimally, then he'll try to maximize the score. Because if he didn't maximize the score, then he need to pick only 7. And later Alice will think in such a way that I'm having 3 stones remaining, out of which 2 stones are having 4, and Bob will have only 1 stone left by the time if I need to pick, because Alice Bob only took one stone 7, so then Alice assumption will be that Bob in the next turn will only be left with the 4 stone, so I'll pick all 9 and 4. So in that case, Bob will also play optimal game. So Bob, what ideally he'll do is he'll just say that no, I won't pick one stone, because in that case Alice will be having 9 score added to it. So or added to her. So I'll just specify Bob that I'll take 2 stones. Now Alice will take. Okay, then I'm not going to give you any chance because I do have 2 4s with me, and anyway I'm going to be a winner. So I'll be having 10 stones with me. Right? Got the point? So in this case, Bob will be having at max how many stones? 16 stones. And we need to return the maximum number of stones that Alice could pick. even though Bob is having more number of stones, but maximum stones that Alice could pick is 10 only. If I just specified Alice that instead of one stone, I'll just pick two stones. Then Alice will say, I'll pick 2 and 7. Then Bob will come and say, okay, then you just take those two stones. I'll take all the remaining stones. 9 plus 4 plus 4 will be my score. So, got the point. And if we observe carefully, this problem is recursive problem. So, why I'm saying this is recursive problem? Because at the beginning of each phase, we do have an x, and also we do have an m, or we do have the piles that need to be taken off. In the other way, I'll just specify if my piles are 2, 7, 9, 4, 4. If my Alice took only 2, then 7, 9, 4, 4 will be there. All the piles of which are containing 7 stones, 9 stones, 4 stones, 4 stones will be there. And Bob again will start from the very beginning, specifying that Ali's current score is 2. Now I need to minimize Ali's score, maximizing my score, because I need to play the game optimally. So how I'll do that? I already told you that this is a recursive function. So every time for recursive function, I like to name it as a helper. And you knew that this problem is ideally based on prefix. I mean the sum of stones or piles that are present in the prefix. So what I'll do is I'll just specify size to be piles dot size, and I'll compute my prefix sum of it. So what is the prefix? Prefix would contain size and initiated with 0. So I'll also specify that my prefix of 0 is equals to piles of 0, and from I equal to 1 till size, I'll just specify that my prefix of I would be prefix of I minus 1 plus my current piles of I, because that's how ideally we'll compute the prefix sum. And I'll just specify what I'll do over here. So here I'll just call my prefix sum, and I'll also call my m, and I'll also call my idx. I'll just specify if int size equals to prefix dot size. I'll just specify my idx is greater than or equal to size. Then I'll simply return 0 because nothing will be added up over there. And I'll also specify my max. I'll just say max choice for x or max x. I'll just specify max x to be, it will be minimum of size minus idx and 2 into m, because if I just specify my m to be 10, or if my m to be 5 and my total array size to be 8, then maximum I could pick only size minus index elements, and I couldn't be going beyond that. So I'll just specify that my max x would be minimum of size minus index and 2 into m. And now I'll just specify int I equal to 1. I could pick anywhere between 1 and max x I plus plus. I'll also call a score. So how I'll be computing the score? Initially my index is 0. So to get uh, index is 0, and in that case I could pick either one stone or two stones, right? If I pick two stones, then I'll add it to the score. So it would be prefix of I minus 1. Why I minus 1? Because ideally I'm specifying that no, it should not be I minus 1, but I plus idx minus 1. Why I plus idx minus 1? So just let me clarify you. So I'll just take this example, 2, 7, 9 followed by 4 and 4. And if I specified that my subproblem is starting from 9, 4, 4, where idx is 2, and I'm just specifying now also x minimum value to be 1 and max value to be 2. So in this case, for computing the sum that I would be getting if my x is minimum or x is 2 would be what prefix. I already computed my prefix sum. So how this would be looking is 2, 9, 18, 22, 26. So in that case, how that would be looking is I'll just specify if my or I'm starting from here, so that would be prefix of I plus idx minus 1 by minus 1, because I in our case is starting from 1. In this case also you could see that idx is 2, I is starting from 1. So 2 plus 1 would be 3, but we are using the zero based index, right? So I just specify that I plus idx minus 1, and I will also specify that if my idx is greater than 0, I'll just subtract my I dx minus 1 to remove all the sum that's added, which is already computed. So in this case, prefix of I plus idx minus 1 minus, I'll just specify, if you consider this example, here it's 18, but ideally it should be 9 only. But why 18? Because we are computing prefix sum. So what I'll do is, to the left part of it, what's the maximum, or the left part of it, till left part of it, the prefix sum is 9. So I'll just remove that 9 from this 18, so that again I'll get 9 only. So in the here also you could check. This is 22, right? In this case, if I'm picking two stones, then what I'll do is I'll just subtract 22, 9 out of 22. So 22 minus 9 would be what? It's 13. So you could check 9 plus 4 is also 13. Ideally, what I'm doing, I'm just specifying, this is my prefix sum. So from my prefix sum, to get the sums from here, I'll just remove this sum computed till this point to get all the values from this point. In the other way, what I'm trying to do is, this is my prefix sum, right? So from my prefix sum to 9, to get this element, what I could do is 18 minus 9 would be what? 9. 22 minus 18 would be what? 4. 26 minus 22 would be what? 4. But instead of getting this, I need to get the sum from this instance to this instance. So to getting the sum from this instance to this instance, or I'll just write it here. For the second one, it would be 2 plus 7. For the third one, it would be 2 plus 7 plus 9. For the fourth one, it would be, I'll just separate this with commas, so making you understand clearly. It would be 2 plus 7 plus 9, and it would be 2 plus 7 plus 9 plus 4, followed by 2 plus 7 plus 9 plus 4 plus 4. So you could check, what I'm trying to do is, to get the sum from this point to this point, I am just specifying that from this point, just remove these values, because these are 2 and 7. And by removing this from this, if I remove this, then I'll be having only 9 and 4, and 9 and 4 are these values only. So I'll just remove prefix of idx minus 1 if my index is greater than 0, and I'll also add an answer value, which is to be minimum at the very beginning. I'll also specify that my answer should be maximum of answer, and my current score is this. And what I'll do is, I'll subtract over here, specifying that this is my current score, and ideally what I need to do is, I need to maximize my score. So to maximize my score, I'll just specify that the opponent score should be subtracted to it, so that my maximum score should be maximized. So m here would be what? Max of im followed by idx. Idx here would be I plus idx. So got the point over here. What I'm trying to specify is, see, in helper, what I'm trying to do is, I'm trying to maximize my score, right? But ideally, it's a min-max game. So if I maximize my score, then I need to minimize other scores, right? Minimize other person's score. But what my helper would be returning? Helper would be returning maximum score only. So in order to achieve the maximum score by minimizing the opponent's score, I have only one option, that I'll just subtract this, specifying that on subtracting this value, I need to get the maximized score, because this is also maximum. Got the point? So I'll just return the answer from that instance, and you could check here, return helper of prefix followed by m1 followed by idx0. I'll just run this out. Yes, now got the point. So one may ask me that we already did everything correct only. but why are we not getting the answer? I'll just specify you the reason over there. So here what we are doing is player 1, who is Alice. Every instance we are computing player 1 max minus player 2 Bob score. Why are we subtracting? I already told you our helper will be computing the maximum value. But for Alice also we need to specify the maximum value that he could obtain on playing the game optimally. So to obtain the maximum, specifying that Bob also will play optimally, both of these are maximum only. So in order to get max value of it, I'm just specifying that score minus this should be maximum at that instance, so that Alice will be getting the maximum score. And effectively what we are computing is player 1's Alice score minus player 2 score. So effective result is player 1 net minus player 2 net. And we already knew that player 1 net plus player 2 net. I mean, both of the players, if played maximum, will get how much score? All the because all these piles should ideally finish up. So player 1 net, player 2 net would be sum of all piles. Sorry, sum of stones in all piles. So what? But I have two equations, and out of these two equations, I'll need to get player 1 score only. So what I'll do is I'll just add them, because player 2 net of Bob here and here will cancel out, and I'll get so I'll just specify prefix of size minus 1 plus I'll just add them, so that I'll get 2 of player 1's net score, and I'll just divide it by 2. Why divide it by 2? Because I'm getting 2 times of player 1 score, and I ideally need only 1 time the score of player 1, so I'll just divide by 2, and it's working fine. But we will end up with many sub problems that are overlapping. So to reduce that, what I'll do is I'll just take a dp. So I'll just specify vector int dp. I'll just specify size for the index and vector int dp, and for m can range till 2 of x can range till 2 of m, so I'll just specify here 2 into size, and I'll just initialize it with -1. I'm pretty sure that this is not required. So I'll just add my DP over here, specifying that there are many overlapping subproblems. So I'll just specify my DP over here, and I'll just check if my DP of index and m not equal to -1. I'll just return DP of index and m. Also here in this helper function, I need to pass the DP over into it, and this problem computed should be saved in DP of index m to finally get the answer. That's how it works. Let me just try submitting this out. It's working fine. Let me just submit this out. Great, we bet 78% people with our algorithm. I'll just specify my C++ compiler not to import any headers from C that are required for taking input or giving output anything to the terminal. So I'll just specify do not import anything for inputting or outputting. I'll just submit this out again. Yes, we bet 82% people with our complexity. Feel free to add anything in the comment section if you think anything is unclear. Thanks a lot for watching this video.